Imagine standing beneath a clear blue sky when, without warning, giant blocks of ice the size of bowling balls crash into the ground. No thunderstorm, no dark clouds, just blue sky overhead. It sounds impossible, yet events like this have been documented around the world, leaving scientists scrambling for answers. Now imagine lightning so powerful it shoots upward into space instead of downward to Earth. Storms that create glowing red explosions above the clouds, and places where rain simply vanishes before it ever reaches the ground. These aren't scenes from science fiction, they're real weather events happening on our own planet. And despite centuries of atmospheric research, some of Earth's strangest weather still refuses to fit neatly into our understanding of physics. Over the next few minutes, we'll follow one extraordinary journey, from mysterious ice falling from empty skies to electric phenomena reaching the edge of space, and discover why our atmosphere is far stranger than most people realize. Because the deeper scientists investigate these events, the more they uncover mysteries hiding in the air above us. Our story begins with one of the most baffling weather events ever recorded. It has a name that sounds almost harmless: megacryometeors. Unlike ordinary hailstones, megacryometeors can weigh several kilograms and fall from skies where no thunderstorm exists. Some of them have smashed through rooftops, destroyed vehicles, and left enormous craters in open fields. In January 2000, Spain experienced dozens of these bizarre ice falls over just a few days. Similar reports have appeared across Europe, India, Brazil, Canada, and the United States. At first, people blamed airplanes. Perhaps leaking water froze around aircraft before falling. But investigators quickly ruled out many cases. Several impacts occurred where no aircraft had passed. Chemical analysis often showed the ice matched normal atmospheric water rather than airplane waste or fuel contamination. That only deepened the mystery. Traditional hail forms inside towering thunderclouds where powerful updrafts repeatedly lift water droplets until they freeze into layered balls of ice. Megacryometeors don't follow those rules. Many appear during calm weather with little or no storm activity. Researchers believe unusual atmospheric conditions in the upper troposphere may allow enormous masses of ice to develop under extremely rare combinations of humidity, temperature, and turbulence. But no single model fully explains every documented event. Some scientists even suspect multiple formation mechanisms may exist. That uncertainty makes megacryometeors one of the least understood forms of frozen precipitation ever recorded. Yet even stranger things happen when electricity enters the atmosphere. For centuries, pilots reported seeing mysterious flashes above thunderstorms. Most people dismissed the stories. How could lightning possibly travel upward? Then, in 1989, everything changed. Scientists accidentally captured a brilliant crimson burst exploding nearly 50 miles above an active storm. The discovery shocked atmospheric researchers. These glowing structures became known as red sprites. Instead of striking the ground, sprites erupt high above thunderstorms in the mesosphere, where the air is incredibly thin. They can stretch more than 30 miles vertically and spread across enormous sections of the sky. For only a few thousandths of a second, they illuminate the upper atmosphere with ghostly red branches resembling giant jellyfish floating in space. They're almost impossible to see from the ground unless conditions are perfect. For decades, humans simply didn't know they existed. Today, satellites, research aircraft, and high-speed cameras have revealed an entire hidden family of upper atmospheric electrical events. blue jets, gigantic jets, elves. Each one behaves differently. Some shoot upward from thunderclouds. Others expand outward in enormous rings near the edge of space. Together, they form what scientists call transient luminous events, brief but powerful electrical phenomena that connect thunderstorms with the upper atmosphere in ways researchers are still trying to fully understand. These discoveries forced scientists to rethink how storms move energy through the atmosphere. Lightning wasn't just striking downward anymore. It was interacting with layers of Earth's atmosphere, once thought almost completely isolated from ordinary weather. And that revelation opened an even bigger mystery, because some of the most powerful weather events on Earth don't happen where people can see them. They happen high above the clouds, almost at the edge of space.
The discovery of red sprites transformed atmospheric science. But researchers soon realized sprites were only the beginning. As more sensitive cameras watched powerful storms at thousands of frames per second, they revealed an invisible world of electrical activity unfolding above nearly every major thunderstorm. One of the most astonishing discoveries was the gigantic jet. Unlike ordinary lightning, which discharges toward the ground, gigantic jets erupt upward from the tops of thunderclouds, punching through the stratosphere and climbing nearly 55 miles into the ionosphere. For a fraction of a second, they create a direct electrical bridge between Earth's lower atmosphere and the edge of space. Scientists had never predicted such a pathway. Even today, researchers are still investigating exactly why only certain storms produce these immense upward discharges, while thousands of seemingly similar storms never do. That mystery has become one of the biggest questions in atmospheric electricity. But electricity isn't the only force capable of creating impossible-looking weather. Travel to some of the driest places on Earth, and you'll witness something equally strange. Dark storm clouds gather, rain begins to fall, yet the ground stays completely dry. This phenomenon is called virga. From a distance, it appears as long, silky curtains hanging beneath clouds, but before the raindrops can reach the surface, they pass through an extremely dry layer of air and evaporate completely. To anyone standing below, it looks as though the rain simply disappears. Although virga itself is well understood, it can trigger something much more dangerous. As evaporation cools the surrounding air, that air becomes denser and plunges rapidly toward the ground. When it hits the surface, it spreads outward as a powerful downburst, producing destructive winds that can exceed 100 miles per hour. Pilots are trained to recognize these invisible hazards because a downburst can suddenly rob an aircraft of lift during takeoff or landing. What begins as rain that never reaches Earth can end as one of aviation's most dangerous weather events. And then there is perhaps the atmosphere's most mesmerizing illusion. On rare occasions, observers have photographed lightning that appears to leap from one storm to another across astonishing distances. Known as anvil crawlers, these sprawling lightning bolts can travel horizontally for more than 60 miles through the upper regions of thunderclouds before finally finding a path to the ground, or never reaching it at all. Instead of following the shortest route, electricity spreads across enormous sections of the storm, revealing just how vast and interconnected these weather systems really are. Every one of these phenomena reminds scientists of the same humbling truth. Earth's atmosphere is not a simple blanket of air. It is a dynamic, layered engine where temperature, pressure, moisture, gravity, and electricity constantly interact in ways that are still being explored. Modern satellites circle the planet every day. High-altitude aircraft sample storms from above. Weather balloons climb into the stratosphere. Powerful supercomputers simulate atmospheric physics with incredible precision. Yet despite all this technology, researchers continue discovering weather phenomena that were completely unknown just a few decades ago. Some are visible for only milliseconds. Others occur so high above Earth that no human can witness them without specialized instruments. Each discovery reshapes our understanding of how energy moves through the atmosphere and reminds us that nature still holds remarkable surprises. When most people think of weather, they picture rain, snow, or sunshine. But hidden above every horizon is an atmosphere capable of creating giant, unexplained ice masses, electrical explosions that reach toward space, rain that vanishes before touching the ground, and lightning that refuses to follow the paths we once believed were impossible. These aren't violations of physics, they're reminders that physics is often more complex, more beautiful, and more mysterious than our first explanations. The sky above us is not fully solved. It is an active laboratory, revealing new secrets every year. And perhaps the strangest weather on Earth isn't the phenomenon we've already discovered. It's the one science hasn't found yet.